Let's talk about reflecting functions. In fact, let's not talk about it. Let's do it. Um, but let me just review for us what a reflection is. So it's the kind of transformation in which all corresponding points um, are uh, are reflected around an axis or a mirror line, so that what ends up happening is, so for a reflection around the y-axis, for example, if this point here was 2 units away from that mirror line or axis, then the new point, the reflected point, is 2 units away, but in the other direction. Um, Likewise, with a vertical reflection, a reflection across the x-axis, if this point was 2 units away from this line, then the new point is also 2 units away, but in the other direction. So let's look at the equations for these reflections. Here's the kind of original parabola: y equals x minus 1 squared plus 2. I made it so its center, or its vertex, is not the origin. I kind of shifted it up so it'd be more obvious. So its horizontal reflection would be more obvious. So that's the original one. And then to flip it across the y-axis to do a horizontal reflection, all I had to do was make that x negative. And then if I were to plot all the new points with the equation, with the only difference being that x is negative, then it flips it across the y-axis. And then for this vertical reflection, all I had to do was make the entire function negative from what it was before. So I could put that in parentheses and just say negative. Um, so that's the relationship between the equations and the graphical transformations, the reflections. So let's focus in on this idea of the reflected points being equally distant from the mirror line, or the line of symmetry about which the graph is reflected, so that we can plot new points easily. So we have this function here. Let's call it g of x. We don't have an equation for it, and that's fine. Let's graph g of negative x. That would be a horizontal reflection, or reflection across the y-axis. And then let's graph negative g of x, which would be a vertical reflection, or reflection across the y, or the x-axis. So let's graph g of negative x. In fact, let's make this a color that we can keep track of. Let's say red is g of negative x. I could just pick a few key points. Let's say points where it's easy to tell where the coordinate is. For example, see how this is at the intersection of these grid lines, and we'll figure out how far they are from the y-axis, and then just put them that distance away, but in the other direction. Um, so this is 1, 2, 3, 4, 5 units away from our mirror line. So 1, 2, 3, 4, 5. That new point is going to be over there. Here, this point is 1, 2 away, so we're going to go 1, 2. Here, 1, 2, so we're going to go 1, 2. What else is easy to tell? This is 0 away, so it's going to stay 0 away. Let's just, come up with enough points to where it's clear how it's going to go. So 1, 2, 3, 4. This point is 4 away, so 1, 2, 3, 4. This is um, almost symmetrical in some ways. What do we have? We did that one. We did, yeah. So 4 and 4. Yeah, it's not quite lined up there, but so yeah. So it's basically going to. Let's see if I just connect the lines, or the new points. Something like that. Um, the more points you do, the more accurate. I'm just going to copy this and rotate it, flip it horizontally, and let's see how well it lines up. Okay, let's make that red. Right, so that would be the horizontal reflection. We're pretty close. I don't know where this point came from. Yeah, anyway. So let's try a vertical one. And let's do more points this time. So we'll do negative g of x. Let's make that yellow. Okay. So this is an outside transformation, outside the function. That means we're flipping it. This is a vertical transformation. We're flipping it vertically, so we're flipping it across the x-axis. So we're going to take our original points and make them the same distance away from the x-axis. So this point was 1 unit away. We'll have a new point there. If this was 1 unit away this way, we'll have one unit away in the other direction. Here we go 1, 2, 3. So 1, 2, 3. 1, 2. So 1, 2. 1. So 1. 1 this way. So 1 this way. Some more obvious points, like roughly 1 up that way. So roughly 1 that way. So let's take a shortcut again where I just copy it, flip it over, and see how it matches up with our points. So pretty good. Pretty good. See how it crosses through. Yep. So that's the idea. Your reflected points are equally distant from the line across which the graph is reflected, just going in the other direction. And you can tell if a reflection has happened based on original function, because if nothing has changed but that the x itself is negative, then you know there's a horizontal reflection, meaning it's flipped across the y-axis. If the whole function is made negative, that's a vertical reflection, so you flip it across the x-axis. So if I were asked to graph, let's say I needed to graph y equals negative x cubed. X cubed. That would be a vertical reflection. Since the negative is on the outside of the function. So I'd flip it. I'd graph x cubed, and then take the points and flip them across the x-axis. So whatever distance they were from the x-axis in one direction, they go that same distance away from the x-axis in the other direction. If I were given y equals negative x cubed to graph, that's a horizontal reflection. So I would do the same thing, but only with respect to the y-axis. So whatever distance something was away from the y-axis in one direction, it would be that same distance away from the y-axis in the other direction.